July 17th, 1940, Butler, Pennsylvania. Karl Probst sits in a hotel room staring at 2 pages of specifications that violate physics. The US Army wants a vehicle that weighs less than 1,300 pounds, but carries 3 soldiers and a machine gun. 4-wheel drive, 50 miles per hour on roads, 15 miles per hour through mud. Climb 45-degree slopes, ford 18-inch streams, cost almost nothing, and they want a working prototype in 49 days. Probst is a freelance automotive engineer. He's designed cars for 15 years. A normal development program takes 18 to 24 months. The Army is demanding the impossible in 7 weeks. Every major manufacturer has already declined. General Motors said no, Ford said no, Chrysler said no. They all said the same thing. The laws of physics don't change because you have a deadline. But Probst doesn't leave the hotel room. He starts sketching on hotel stationery. What he draws that night will become the most important vehicle of World War II. It will serve on every battlefield from North Africa to the Philippines. Patton will demand more of them. Montgomery will use one as his command vehicle. Stalin will toast its importance at Tehran. But right now, it's just pencil marks on paper and a deadline that's already ticking. 49 days, 1,176 hours. The clock starts now. Here's what makes the Army's specifications absurd. A 1940 automobile weighs 3,000 to 4,000 pounds. The Army wants something that weighs 1,300 pounds. That's a motorcycle with a sidecar. Except this motorcycle needs to carry 3 men, a machine gun, ammunition, supplies, and have 4-wheel drive. The math doesn't work. Probst knows it doesn't work, but he also knows why the Army is desperate. In May 1940, German panzer divisions smashed through France at 50 miles per day. American military observers watched French cavalry trying to respond on horses that moved 20 miles per day. By the time French commanders received intelligence, it was 6 hours old, and the Germans had already moved. The United States Army still has 20,000 cavalry soldiers. They're obsolete, and everyone knows it. So Probst starts with the weight constraint and works backward. Every component must justify its existence. A conventional car frame weighs 600 pounds. Probst designs a simple ladder frame with minimal cross-bracing, 400 pounds saved. A typical car body uses formed steel panels with complex curves, doors, roof, trim, 800 pounds. Probst specifies flat panels, no doors, no roof, no trim, 500 pounds saved. A standard engine weighs 600 pounds. Probst selects a tiny Continental 4-cylinder at 320 pounds, 280 pounds saved. He works for 2 days straight. On July 19th, he presents drawings to Bantam Car Company. The vehicle looks like something drawn by a child. Flat panels, vertical windshield, exposed wheels, no curves, no style, no concessions to aesthetics. Harold Christ, Bantam's chief engineer, studies the drawings and calculates weight. This will weigh 1,850 pounds, he says, not 1,300. Probst spends another week cutting weight. Thinner frame rails, thinner body panels, no spare tyre mount, no front bumper, smaller fuel tank. By July 27th, he's at 1,550 pounds, still 250 pounds over specification, close enough to build. The real innovation isn't weight reduction. It's how Probst solves the 4-wheel drive problem. In 1940, 4-wheel drive is rare and complex. Heavy trucks have it. A few specialty vehicles, nothing lightweight. The standard approach uses a transfer case with multiple gears, differentials, and complex linkages. It weighs 300 pounds and brakes constantly. Probst designs something simpler, a transfer case that shifts between two-wheel and four-wheel drive. When you're on a road, you run two-wheel drive, save wear, improve fuel economy. When terrain demands traction, you pull a lever and engage four-wheel drive. The system is crude, but it works, and it weighs 150 pounds, half the weight of conventional systems. The suspension is equally radical. Normal cars use leaf springs with complex mounting points, heavy, expensive, time-consuming to install. Probst specifies simple leaf springs mounted directly to the frame. No sophisticated geometry, no isolation bushings. The ride will be harsh. Soldiers will feel every bump. But it works, and it's light, and it can be manufactured fast. The steering system borrows from agricultural tractors, a simple recirculating ball system connected directly to the front wheels. No power assist, no sophisticated linkages. Steering will be heavy. Turning the wheel will require actual physical effort, but it's reliable and it's light and it won't break. By September 1940, Bantam's 50 workers have hand-built a prototype. No production tooling, no assembly line, just skilled craftsmen fabricating each component individually. The body panels don't fit perfectly. The welds are visible. The paint is non-existent, just raw steel. But on September 21st, 49 days after Probst started sketching, the vehicle runs. Probst drives the prototype from Butler to Camp Holabird in Baltimore, 250 miles through Pennsylvania and Maryland. No doors, no roof, no heater, September weather. Every bump transmits through the frame directly to the seats. The engine is loud, the steering is heavy, the ride is punishing. But something becomes clear during those 250 miles. This crude little vehicle works. Probst takes it off-road multiple times, through mud, over railroad tracks, across fields. The four-wheel drive provides traction that seems impossible for something this small. The short wheelbase, just 80 inches, allows it to turn in spaces where normal vehicles would need three-point turns. The ground clearance, 9 inches, lets it drive over obstacles that would stop conventional cars. At Camp Holabird, Army engineers spend 2 weeks testing. They drive it over obstacles, through water, up hills that stop military trucks. They load it with soldiers and equipment far exceeding rated capacity. They run it at maximum speed for hours. They try to break it. It passes every test except weight. On the scales, 1,840 pounds, 540 pounds over specification. The Army notes this in their report, but they're impressed. Major Herbert Laws writes, "The vehicle demonstrates feasibility. Performance exceeds expectations. The weight is a concern, but the concept is viable." But now comes the betrayal. The Army gives complete Bantam specifications and test data to Willys Overland and Ford. Bantam's intellectual property handed to competitors who have manufacturing capacity. Bantam lacks. It's legal but brutal. Willys engineer Barney Roos studies the Bantam prototype in October 1940. He sees what Probst created and recognizes the limitation. The Continental engine produces adequate power, but no reserve. Load the vehicle heavily, or operate in heat or altitude, and it struggles. Roos specifies the Willys Go Devil engine. 4 cylinders, 60 horsepower instead of 45. More power means more weight, but Roos believes performance justifies it. The Willys prototype, called the Quad, weighs 2,030 pounds when delivered in November 1940. Massively overweight, but it climbs hills the Bantam can't. Ford enters with the Pygmy, closer to Bantam's original design. Better manufacturing quality, £1,840. The Army tests all three through winter 1940 to 41. Each has strengths. Bantam is lightest. Willys has best performance. Ford has best manufacturing quality. In June 1941, the Army makes a brutal decision. They'll standardize specifications combining the best features of all three: Willys engine, Ford body improvements, Bantam chassis layout. All three companies will build 1,500 units each to the standardized design. For Bantam, this is death. They can't match Willys and Ford production capacity. By 1942, Bantam is out of Jeep production entirely. Karl Probst's design becomes the foundation for 640,000 vehicles built by companies that didn't invent it. The standardized vehicle receives designation Truck 1/4 ton 4x4, but soldiers call it the Jeep, military slang for new unproven equipment, derived from Eugene the Jeep cartoon character that could go anywhere and do anything. Willys trademarks the name in 1943. By mid-1942, Willys produces 700 Jeeps daily. Ford exceeds 1,000 daily. This is where the real revolution occurs, not in the design, but in the manufacturing. Early Jeeps require 150 worker hours to assemble. Too slow. Engineers study every operation. They break complex tasks into simple, repeatable steps. A worker doesn't learn to build a complete Jeep. They learn to install seats, or connect electrical systems, or mount wheels. That specific task, repeated hundreds of times. Specialization allows rapid training. Traditional automotive workers trained for years. Jeep workers train for weeks. By 1943, assembly time falls to 50 worker hours per vehicle. Ford's most efficient facilities achieve 40 worker hours using extreme standardization. Component standardization is critical. Every bolt in every Jeep is identical. Every electrical connector, every gasket. This simplifies supply chains and enables field repairs. A mechanic in North Africa can use parts from any Jeep to fix any other Jeep, regardless of manufacturer. The parallel production approach seen in Liberty ships appears here too. While one line installs engines, another fabricates frames, another assembles transmissions. Components converge on final assembly, where complete Jeeps emerge in hours. Cost falls from $900 per vehicle in 1941 to $750 by 1943, despite rising wages and material costs. Volume creates efficiency. At peak production, 1,700 Jeeps emerge from American factories daily, more vehicles than the Army can initially absorb. The Jeep enters combat in North Africa, November 1942. Its impact is immediate and transformative. Within weeks, commanders realize they have a vehicle that redefines tactical mobility. Reconnaissance. A reconnaissance platoon on foot covers 20 miles daily. With Jeeps, they cover 200 miles daily, 10 times the range. This changes what's possible. Units can scout ahead of main forces, identify enemy positions, and return before the enemy reacts. The short wheelbase and four-wheel drive allow movement through terrain impassable to conventional vehicles. Command and control. Traditionally, battalion commanders stayed at headquarters, sending orders by messenger. With Jeeps, commanders drive to the front, observe personally, make immediate decisions. Lieutenant General James Gavin, 82nd Airborne Division. The Jeep transformed airborne operations. Paratroopers jumped with nothing but what they carried. Hours later, jeeps arrived by glider. Suddenly we had transportation, firepower, mobility. We could sustain combat operations instead of brief raids. Mobile firepower. Mount a .50 caliber machine gun on a jeep and you have mobile firepower equivalent to a dozen infantry. The vehicle provides 360-degree traverse, rapid position changes, and the ability to engage and disengage at will. British SAS in North Africa stripped jeeps to bare essentials, mounted multiple machine guns, added extra fuel and ammunition. These desert jeeps operated hundreds of miles behind Axis lines, destroying aircraft on the ground and vanishing before defences could respond. Medical evacuation. Before jeeps, wounded soldiers were carried by stretcher bearers. Slow, exhausting, often too late. Jeeps modified as ambulances reached casualties quickly and transported them to aid stations while treatment could still save lives. Army medical statistics showed survival rates increased significantly in units with jeep ambulances. Logistics revolution. Traditional armies moved supplies by truck convoy on roads. Jeeps delivered supplies cross-country directly to frontline units. Patton's rapid advances across France in 1944 were sustained by jeeps carrying fuel and ammunition to units that had outrun conventional supply lines. When tanks ran dry 50 miles ahead of supply convoys, jeeps with jerry cans arrived cross-country and kept the advance moving. Weapons platform evolution. By 1944, jeeps mounted increasingly heavy weapons. 37mm anti-tank guns, 75mm recoilless rifles, multiple .30 and .50 caliber machine guns, rocket launchers. The vehicle became a mobile weapons platform limited only by crew imagination. The real-world performance data revealed capabilities that surprised even Army engineers. Mobility, 9 inches ground clearance, 80-inch wheelbase creating 25-degree approach angle, 35-degree departure angle. Could ford 18-inch streams as specified, but soldiers routinely drove through 30-inch water with proper preparation. Climbed 60-degree slopes, exceeding the specified 45 degrees. Reliability. Quartermaster Corps maintenance records from 1944 showed jeeps operated approximately 1,200 hours between major mechanical failures, better than any other wheeled vehicle in Army inventory. The simple mechanical design meant fewer components to break. The Go Devil engine was crude but nearly indestructible. Fuel efficiency, 16 miles per gallon on roads, 12 off-road. The 15-gallon tank provided 240-mile road range, less cross-country, adequate for tactical operations and better than vehicles twice its size. Payload reality, rated for 800 pounds, but routinely carried 1,200 plus pounds. Driver, 3 passengers, weapons, ammunition, supplies, equipment. The suspension bottomed out, but the vehicle kept functioning. Soldiers learned to trust it with loads engineers never intended. Combat losses, 640,000 produced, approximately 145,000 lost to enemy action, accidents, abandonment. 22% loss rate. High, but reflecting frontline use where losses were inevitable. Rapid production meant losses were replaced faster than units could deplete them. The Jeep proved 3 revolutionary principles that changed military procurement and industrial design forever. First, extreme constraints drive breakthrough innovation. The 1,300-pound weight limit seemed impossible, Pursuing it forced elimination of everything non-essential. The result was more functional than an unconstrained design would have been. Probst later said, "Limitations forced us to identify what truly mattered. We couldn't add nice-to-have features, only must-have capabilities." Second, rapid prototyping reveals truths that theoretical analysis cannot. The Jeep worked not because calculations predicted success, but because they built it and tested it. Problems discovered in testing were solved immediately rather than analyzed endlessly. This compressed years of traditional development into weeks. Third, good enough delivered fast beats, perfect delivered late. The Jeep was crude, uncomfortable, unsophisticated, also functional, reliable, and available in massive quantities when needed. Perfect vehicles still under development have zero impact on battles happening now. These principles influenced military procurement for decades and anticipated lean development, agile methodologies, and minimum viable product concepts that dominate modern technology development 50 years later. The cultural impact extended beyond military applications. When World War II ended, Willys developed civilian versions. Farmers discovered Jeeps were ideal for rough terrain. Rural mail carriers reached isolated customers. By 1950, Willys produced 1,200 civilian Jeeps weekly. The emergency military vehicle became a commercial success. Other nations copied the design. Land Rover in Britain, Toyota Land Cruiser in Japan, Soviet Gaz 67. The basic Jeep architecture became the template for utility vehicles worldwide. By 2020, the Jeep brand generated over $22 billion in annual revenue, with production exceeding 1.5 million vehicles annually. The Jeep Wrangler, direct descendant of Probst's original design, remained in production 80 years after those first sketches on hotel stationery. But the real legacy isn't vehicles sold or revenue generated. It's what the Jeep proved about human capability when urgency meets creativity. 49 days from concept to working prototype. 4 years from zero production to 640,000 units. A vehicle designed by an outsider, unconstrained by industry assumptions, built by workers trained in weeks, not years, used by soldiers who trusted it with their lives. The Jeep demonstrated that impossible is often just a failure of imagination. That revolutionary improvement requires revolutionary approaches, that the greatest innovations come from those willing to question whether limitations are real or merely accepted. In 1940, automotive experts said you couldn't design and build a capable military vehicle in 49 days. Karl Probst proved them wrong with pencil sketches on hotel stationery. The result changed every battlefield of World War II and influenced vehicle design for the next 80 years. Jeep is the proof that when necessity demands and creativity responds, humans can accomplish what conventional wisdom claims impossible. The Jeep didn't just win a war, it demonstrated what's possible when we stop accepting limitations and start solving problems.